In this video, we'll be going over clone graph. So given a reference of a node in a connected undirected graph, return a deep copy, a clone of the graph. Each node of the graph contains a value, which is an int and a list of neighbors. So we're given this class where the node has a value and also a list of neighbors. And then our first example we're given this original graph and then we're trying to clone the exact copy. We also need to maintain a structure of the original graph. Let's go over the thought process. So we will be implementing a recursive approach to clone the graph. So for each of the node x, we will first need to create a clone of x. Then we will need to iterate through the neighbors of x. We will want to clone the neighbor of x before connecting the clone neighbor to clone, which is our current clone. A side case we have to handle is we should note that the input graph may contain cycles. This means we may visit a node x multiple times, and we do not want to clone x multiple times. We will need a way to save previously cloned nodes of x. This means we can create a hash map where we keep track of x to its clone. Then we can check the map to see if we have already cloned x or not. Now let's go over the pseudocode. So we're going to implement our recursive approach. And now what parameters do we need? We'll need the current node that we're visiting, which is our node. The current node we are cloning. And also the map is hash map to keep track of previously cloned nodes. And then what's the base case? If node is null, this means we cannot clone it. We can just return null. And if map contains node, which means we have already cloned node before, so we can just return map.getNode, which returns the clone of the current node. Then in each of the recursive call, we're going to create a clone of node. Now we want to put node and clone into our map. This allows us to keep track of previously cloned nodes. Then we can iterate through the neighbors of node. We can just denote this as neighbor. Then we want to create a clone. We're going to recursively clone the neighbor, which we can call y. So node turns to neighbor because we want to clone the neighbor. Then we can add y to the list of neighbors of the current clone. Then we can return the current clone. Now let's go over the time and space complexity. For the time complexity is O of n plus e, where ne are the number of nodes and edges. This is because we visit all of the nodes and edges. Visit all nodes and edges. And then the space complexity is O of n plus e plus O of n. So it's equal to O of n plus e. So O of n plus e, this is our newly generated clone of the input graph. And then O of n is the recursive call stack memory. Actually, we can have another one, which is another O of n, which is our map. Now let's go over the code. We're going to implement our recursive approach, passing in our current node and also a new hash map to keep track of previously cloned nodes. Then if node is equal to null, this means we cannot clone the current node, we can just return null. And then if map contains node, which means we have already cloned this node before. We can just return the cached results. Now we want to create a clone of the current node using the same value. Then we want to put the current node and also the clone into the map. Then we iterate through the neighbors of the current node. Before we add the neighbor to our clone, the neighbors of the clone, we want to clone this neighbor first. So we want to do clone.neighbors.add. We want to clone it first. So clone neighbor and also passing out map. Then we can return the clone. Let me know if any questions in the comment section below.